In this question, matrix A is given and condition is given, which is A into A transpose is an identity matrix. And we need to find the value of alpha power 4 plus beta power 4. So first we need to find the value of alpha and beta. So let's use the condition given, that is A into A transpose, which is nothing but 1 minus alpha, alpha, beta. This is A, and A transpose is 1 minus alpha, alpha, and beta. Just multiply it, you'll get 1 plus alpha square, alpha minus alpha beta, alpha minus alpha beta, alpha square plus beta square. Now equate this LHS with the RHS, that is I2. When you equate it with this I2 matrix, you will get 1 plus alpha square as 1 and alpha minus alpha beta is 0. So from this equation, take alpha common. The remaining is 1 minus beta, that is 0. You will get 1 minus beta is 0. So beta is 1. And here you'll get alpha as 0. So alpha is equal to 0 and beta is equal to 1. So when you substitute here 0 power 4 plus 1 power 4, you will get 1. So 1 is the required answer for this question. In this question, it is given as A be a symmetric matrix, which means A transposes A. This is the condition for the matrix to be symmetric of order 2 with integer entries. And if the sum of diagonal entries of A square is 1, then the possible number of matrices are. So first, so A is a symmetric matrix. For this, we need to assume A matrix as A, B, B, and C. Because when you do the transpose, it remains the same. So after this, just multiply it to get the A square. Here, we only need the diagonal elements, so just multiply to get diagonal entries, that is A square plus B square. And here's something you'll get, and here also something you'll get. Here you'll get B square plus C square. Okay. Now the sum of the diagonal entries, that is A square plus 2B square plus C square is 1. Here only integer entries are used. Here entries. So here only integers are used. So B will be 0 only. For A, you have two chances, that is plus or minus 1. So here in this case, C will be 0. If A is 0, I already told B is always 0, and C will be plus or minus 1. From here, you will get two chances, that is 1, 0, 0, minus 1, 0, 0. And here also you'll get two chances, 0, 0, 1, 0, 0, minus 1. So in total, you'll get four chances. So 4 is the required answer for this question. In this question, matrix A is given and we need to find the value of this. So in these kind of questions, first we need to find the pattern of a matrix. First, let's take A square and let's see what the pattern is. Let's take A cube, that is A square into A. Actually, here 1 will come and here also 1 will come. So when you multiply this, you'll get it in this way, that is 1, 0, 0, 2, 1, 1, 1, 0, 0. So you can observe that when you take a square over here, when you take a square over here, you are getting 1 here, right? When you take a cube, you are getting over here 2. So we can write it as a power n is nothing but 1, 0, 0. And here it becomes n minus 1 because when we are taking a cube, we are getting as 2, right? So here 1, 1, and here 1, 0, and 0. So this is the a power n matrix. So when we take a power 2025, we'll get it as 1, 0, 0, 2024, 1, 1, 1, 0, 0. And a part 2020 can be written as 100 2019 11100. And when you subtract these two, a part 2025 minus a part 2020, you will get it as 000500000. So this is the required answer. But in our options, it is given like these. So you can cross check over here. A power 6 is nothing but you will get it like this 100511100. So this is not the correct answer. Similarly, it's like the same a power 6, but instead of 5, you will get it as 4 for a power 5. When you see this a power 6 minus a, so when you solve option C, a power 6 minus a, that is 100511100 minus the A matrix, that is 100011100. So when you subtract it, you'll, I hope you can get right. So this is what we want. This is the answer what we got. So this is the correct answer for this question.